explanation tutorial. If you're used to my videos, this is be a bit different as I'm doing it as a presentation. If you're here because you found this by searching for the math, this video is geared towards relaxation, but the math is legitimate, so it might be useful. In any case, hi everybody, and I hope this serves whatever purpose you found yourself here for. So let's begin. This is going to be about solving quadratic equations. I thought at first I would do just a quick review on just solving an equation in general. So let's start there. Here's an equation. 3x minus 5 equals 7. Basic equation. One variable, x. Pretty basic. The idea is solving for x is to isolate x. Getting it by itself. So the first thing would be to isolate the x term. So, doing the same thing to both sides of an equation, let's eliminate this guy by turning him into 0. Well, minus 5, let's add 5 to both sides of the equation. So we can see that here, that kind of cancels itself out, and we'll be just left with the 3x as desired. And over here we'll evaluate, and 7 plus 5 will equal 12. Voila! 3x equals 12. Again, our strategy is to isolate the x. So I have 3x. Let's multiply by 1/3. 1/3 times 3 would give me 1. Thus isolating the x. Again, we gotta do the same thing to both sides of the equation. 1/3 and 3 will cancel out, leaving just the 1, x. And then evaluating 12 times 1/3 will give us 4. So x equals 4. Not so bad, eh? Now, as any good mathematician or student of mathematics, we should check our results. So plugging 4 into the original equation, 3 times 4 minus 5 equals 7. Is that true? Well, there we go. Plugging the 4 in, 3 times 4 gives us 12. And evaluating this side, 12 minus 5 gives us 7. And 7 equals 7. Yay! It's a solution. Now here we go. That's a little scarier. This is a quadratic equation. Quadratic because we've got a squared guy there. Equation because, well, we've got an equal sign there. Quadratics are a bit different as we have the squared term. Let's look at just the general form. General form because, as we mathematicians like to do, we've got letters for the numbers, because they could be any old number. Again, the key to making this quadratic is that I've got a second degree term. And these coefficients for each term. Let's go back to this guy. In this case, my a's is just simply 1. The b, or the second coefficient, is 3. What's up here? Well, this isn't in standard form. Standard form, the equal to 0 bit, is kind of important because something is cool about 0. What's so special about 0? Well, it's the additive identity. Nice bit of vocabulary. Let's see what that's really about, though. 0 has some cool properties. If you add something to 0, you just get itself. And if you multiply by 0, you get back to 0. This second bit is kind of going to be important. Let's just generalize. Basically just stuck in an n for the 5. Again, us mathematicians and math geeks and math students, etc. N just means any old number. It doesn't have to be 5. It could be 56. It could be -2. It could be 10 million, who knows. But whatever it is, plus 0 is whatever it is. And whatever it is, times 0 is always 0. Again, the second bit is the thing that's going to be important to us. Because anything times 0 is 0. So, something times something else equals 0. Well, the only way that works out is if one of those guys is in fact a 0. So, either A is 0 or B is 0. And you may be thinking, yeah, anything times 0 is 0. Okay, cool. How can we use this? Well, it's going to be the way we solve quadratics. I mean, look at this guy again. We can't do our normal isolate the x. I've got all the x's on one side, but you probably remember, Bill, I can't combine those. They're not like terms. And you'd be right. So we're going to use that something times something 0 business to our advantage. So let's set the whole thing equal to 0. Basically setting this side to 0 and just sort of living with whatever we get over here and evaluating x plus 3x plus 2 equals 0. Okay, now I've got it equal to 0, but I don't have something times something equal to 0. How to accomplish this? Factoring. You probably had to spend a fair amount of time learning how to multiply binomials into trinomials and then undo it into factors, and probably wondered the whole time, why is factoring so important? Well, here's one of the reasons factoring is our friend. Let's look at two simple binomial factors. X plus 1 and x plus 2. And remember, there's a way of multiplying these together. a trinomial. A common terminology for this method is the FOIL method, meaning first, outside, inside, last. So first, x times x gives us x squared. X times 2 is 2x. 1 times x is simply x. And 1 times 2 is basically 2. And remember, we can collect up and combine our like terms. So here we go. X plus 3x plus 2 might seem familiar. That was our quadratic equation. So that this guy and this guy are the same thing. Cool. Now I have something times something equals 0. Now we can use that principle. That means either this or this equals 0 specifically. If this whole thing equals 0, then one or the other of these two binomials is 0. Then either x plus 1 equals 0 or x plus 2 equals 0. Looking at the first, pretty straightforward. We get x is equal to -1. Looking at the second, again pretty straightforward. We get x is equal to -2. Now, plugging them both in, again, we should always check. And just evaluating, putting in -1 for x. -1 squared is 1. 3 times -1 is -3. The 2 is just along for the ride. And again, looking at this line, moving from left to right, 1 plus -3 is -2. And we see that -2 plus 2 is 0. Checks out fine. Let's plug in our -2 and go through the same sort of process. -2 squared is 4. 3 times -2 is -6. 2 is just along for the ride. Again, evaluating from left to right. 4 plus -6 is -2. And again we see -2 plus 2 is 0, which checks out fine. So, we saw that our original quadratic could be written in an equivalent form with 2 factors, which leads us that -1 gives us 0, or -2 gives us 0, and we say that x equals the solution set of -1 and -2. Okay, let's try another one. Again, we're going to use our skills at factoring. This time, again, using a fairly simple example. Got a quadratic equation in our standard form equal to 0. Now we want to factor this into 2 binomials. So we want it to this basic form, filling in our blanks. Well, here we know from experience those are both going to be x's. It's filling in this bit that's going to be a little tricky. But again, I've chosen a fairly simple example. I want these two numbers to multiply to give me a positive 6, as they should result in this term. But that will ultimately add to give us negative 5. Multiply to get positive 6, but add to get negative 5. Well, negative 2 and negative 3. Negative 2 times negative 3 is positive 6, and negative 2 plus negative 3 is negative 5. And just for ease of notation, instead of negative 2 and negative 3, I'm just going to write x minus 2 and x minus 3. So, this is equivalent to this in our factored form. Let's just make sure. Going through, x times x is x squared. X times negative 3 is negative 3x. Negative 2 times x is negative x. And negative 2 times negative 3 is positive 6. And combining our like terms that are just x, yep, that's what we want it to be. So, this original equation is equivalent to this in its factored form. So, this factor equals 0, or this factor equals 0. So we can readily see that x equals 3, or x equals 2. Or we say x is equal to the solution set 2 and 3. Now, again, looking at just a standard form of a quadratic equation, these values don't have to be so simple as 1s and 2s, etc. They could be any number. And you might think, well, that might make it difficult to factor, and it can. And there are techniques for factoring. But I won't go into those. You can review those if you're in a class. I wanted to present a formula, something that would just work every time, just in case you don't see how to factor, you don't remember how to factor something too complicated. And the formula itself can be a bit complicated to look at first, but it will always work. Again, looking at our standard form of the equation, I want to develop something that will work no matter what A, B, or C might be. And I want to be able to do this so I have a solution for x for any A, B, and C. a strategy. Well, our strategy is going to be completing the square. Hopefully you'll remember this from when you talked about things in your class about factoring. Completing the square, what we want to do is end up with something that looks like this. And you'll remember that this is simply this, which when multiplied out gives us this. Now this seems a bit complicated, but you'll bear with me, I hope. If we look at this last term through a little bit of algebraic manipulation, it could be rewritten like this, which might look a bit like gobbledygook. But the main thing I want to point out is that it looks a bit like taking this term and kind of fiddling with it a little bit. And that's precisely what we're going to do. We're going to take this term, fiddle with it in order to end up with this term. Just don't worry about the details so much right now, but just that that's what we're going to do, is fiddle with this guy to end up with the appropriate pattern that gives us the square. So, starting here, what are we going to do? Well, this part gets a bit complicated, so just try and follow along. I will try to be as clear as I can. First, we want to get this first term to be just a 1, so we will divide everything by a. So, divide all of that by a, and again, we must do the same thing to both sides of the equation. Now, simply evaluating term by term, ax squared over a by itself, the a's just drop out and we're left with x squared. Taking this term, can't do much with it, so we just write it b over a. Same here, can't do much with it, so it's c over a. And again, evaluating 0 over a, simply 0. Now, we want to get the x bits by themselves, so eliminating this bit, and again doing the same thing to both sides of the equation. So, subtracting this part, we'll just evaluate to 0, doing the same thing on both sides, and essentially evaluating. We are left with just the x squared. This term, not much happened, and now this guy is over here by himself, and you'll notice with the opposite sign. Now here comes the bit. Taking this guy and tinkering with it, essentially introducing a factor of 2 and adding it, back up, introducing the factor of 2, taking the whole thing and squaring it. But we have to add that to both sides. Starting to look a little complicated. But that's all right. going forward. This whole mess will evaluate to a perfect square, again using the technique of completing the square. If you want to go back and check your own notes about the technique, this is where it works out to. Evaluating this side, b squared, evaluating the denominator, and over here, essentially just giving us a common denominator. Since this is 4a squared, my numerator here needs to have an extra 4a, as that's what I had to apply to this denominator. Still pretty messy. Well, I have this bit here, and it's squared. Well, let's take the square root of both sides. Taking the square root here, and if you'll remember, when you take the square root, you get a plus minus. Simple example, the square root of 4 can be 2 or negative 2, right? 2 times 2 is 4. Negative 2 times negative 2 is 4. So we say plus or minus. And essentially just putting all of that under the radical. Now we can do a little bit of evaluation. Clean it up a touch, not a whole lot though. The square and the radical just disappear, leaving us x plus b over 2a, just essentially rewriting that mess there. Equals, not much we can do over here, except evaluate the denominator. Square root of 4 is 2, square root of a squared is a, the rest we just leave alone. Now we're almost there. Just need to get rid of this bit here. So, subtract it. It'll go to 0. Remember, we must do the same thing to both sides. Basically just rewriting that. And now combining so we have everything over one denominator. And voila, there is our formula. It looks a little scary at first until you're unused to it. Maybe I misspoke. It looks a little scary until you're used to it. The good thing is, it works no matter what A, B, and C might be. Okay. Making use of this formula. Here's our standard form, just as a guideline, so we know what's A, B, and C. Let's look at this equation here. A is 2, B is 5, and C is negative 12. Let's just plug in the values. So, negative b, negative 5, plus or minus b squared minus 4 times a times c, all over 2 times a. A big mess, but we've got everything plugged in okay. So let's just evaluate. Negative 5 plus or minus. Let's evaluate 5 squared. Gives us 25. this here, 2 times negative 4 is negative 8 times negative 12, 80 plus 16, negative 12, and that gives us a positive 96. Break out your calculators to check my arithmetic if you'd like. All over 2 times 2 is 4. Evaluating under the radical, 25 plus 96 is 121. So, negative 5 plus or minus the square root of 121 over 4. Well, that evaluates nicely. The square root of 121 is simply 11. So, I have negative 5 plus or minus 11 all over 4. Let's take the plus choice first. X equals negative 5 plus 11 all over 4. Negative 5 plus 11 is 6 over 4, which reduces to 3 over 2. Not so bad, really. Let's take the minus choice. Negative 5 minus 11 all over 4 equals, evaluating this, negative 5 minus 11 is negative 16 over 4, which reduces to negative 4. Not so bad. So here's our two choices for x. X is the solution set of 3 halves and negative 4. So that's our solution. Again, as good math students, we want to plug in and evaluate. Taking 3 halves in for x. So 2 times x squared, putting 3 halves in, plus 5x, putting 3 halves in, minus 12. Now let's evaluate, going from left to right. 3 halves squared is 9/4. 5 times 3 halves is 15 halves. And we'll just bring along the minus 12 for the ride. I notice here that this can reduce, so I'm left with 9 halves plus 15 halves minus 12. Combining these first two terms, 9 plus 15 is 24, halves minus 12, but 24 halves is 12, minus 12 is 0. That solution checks out fine. Let's plug in the negative 4. So 2 times x squared. So we plug in the negative the negative 4 in for x and evaluate. Negative 4 squared is 16. 5 times negative 4 is minus 20. And the minus 12 just comes along for the ride. So 2 times 16 is 32. Minus 20, minus 12, they're just along for the ride. Let's evaluate. 32 minus 20 is 12. Minus 12 comes along, but 12 minus 12 is 0. Checks out fine. So there you have it. A nice little formula. Maybe a little bit complicated to use, but guaranteed to work. So, that'll be it for for today. I hope you found it entertaining, informative, relaxing. Anyway, until next time, this is Bill, signing off.